Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So this is our lecture number 1 on functions. Okay, very important topic for JEE point of view as well as for board's point of view. Okay, so we'll be learning in depth about functions, what are the types of functions. But before learning about function, you should know about what are sets and what are relations. Because function is basically some special type of relation. So you need to know about relation. So I will be giving you a quick recap about sets and relation before starting functions. So if you haven't studied about sets and relation, you can watch the previous lecture on sets and you will get the entire detail about sets and relation. Here I will be just giving you a quick recap about what are sets, what are relations, how they are defined. So first of all, let's get started with that. Then later on we'll learn about definitions of functions and types of functions. Okay, so hashtag recap. So I hope all of you know what are sets, right? What are sets? Sets are nothing but collection of elements. That's it. Sets are nothing but collection of elements. Here the order does not matter, right? I can represent a set as set of these numbers, right? There are 3 numbers in this set. Here the order will not matter. Set 1, 2, 3 or whether I call it 3, 2, 1, both of them are the same set because their elements are same. So basically in set, the order of the element does not matter. We have learned about sets like set of real number, capital R. This is basically set of all real number, right? Every real number, that is capital R. Then we have learned about N, which is set of natural number. Set of natural number. These are basically infinite set. There are infinite elements in these set. Set of natural number, which can be written like this, which can be represented like 1, 2, 3, 4 and so on. I hope all of you know that 0 is not included in natural number. Then we represent W, which is set of whole number. Set of whole number. In the set of whole number, we have 0, then 1, then 2, then 3, then 4, and so on. So this is basically what we mean by set. Okay. Then we learn about Cartesian product of two set. The second thing that you need to know, this is just quick revision. Cartesian product of two sets. So we define Cartesian product of two sets like this, okay? Like suppose for an example, there is a set of elements 1, 2, 3 and there is another set A comma B, okay? So Cartesian product of these two sets is also a set, okay? And that's the first thing. That Cartesian product of two set is what? That is a set. Now, this is the set of ordered pair. This is the set of ordered pair. Now, ordered pair is represented like this. Ordered pair is represented like this. A comma B, something like that. Here the order will matter. A comma B is not equal to B comma A. This is not equal to B comma A because there is a order. The name in it is ordered pair. So here the order will matter. A comma B is not equal to B comma A. But if I say set A comma B and set B comma A, they are same. They are equal because this is set. This is the definition of set. In ordered pair, the order is going to matter. Like suppose you have used this representation in coordinate geometry as well, right? Like if I say 2 comma 3, 2 comma 3 means x coordinate is 2, y coordinate is 3, but that is not equal to 3 comma 2 because now it will represent that x coordinate is 3 and y coordinate is 2. These two are different points. Okay, so we use order pair in representing the coordinate. We use order pair to represent the coordinate in coordinate geometry. Okay, so this is where you have seen these ordered pair and now you are going to see these ordered pair in the definition of Cartesian product as well. So the definition of Cartesian product is that Cartesian product of two sets is also a set of all the ordered pair. set of all the ordered pair where the first element will come from the first set and the second element will come from the second set. So all the ordered pair that I can make, like 1 comma a, 1 comma b. Okay, first element is coming from this, second element is coming from this. So I am writing 1 comma a, 1 comma b. Then I have 2 comma a, 2 comma b, 2 comma a, 2 comma b. Then I have 3 comma a, 3 comma b, right? 3 comma a, 3 comma b. This is Cartesian product of these two sets. Okay, and here you need to remember this property. I hope you understand that a cross b is not equal to b cross a. A Cartesian product b is not equal to b Cartesian product a. Okay, because see, in this Cartesian product, the first element is coming from set A and the second element is coming from set B. But in here, the first element is coming from set B and the second element is coming from the set A. So they are not going to be equal. Let me show you through an example. Like if I do this, A comma B, Cartesian product 1 comma 2 comma 3. Now, what will be the Cartesian product of these two sets? So the Cartesian product of these two sets is also going to be the set. Here the first element comes from set A, second from set B. So it is going to be A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma 3, right? So here we have A comma 1, A comma 2, A comma 3, B comma 1, B comma 2 and B comma 3. Okay, this is the Cartesian product of two sets. I hope you have learned about that in the previous lecture. This is just a recap about that, because before starting functions, I want to remind you again about all the related things, right? Like sets, Cartesian product, and then relation. Okay, so I hope you have understood about the Cartesian product. Now, what is relation? Relation is just a subset of these Cartesian product. If I take any subset of this Cartesian product, I will get a relation, any subset. Now, I hope you remember what are subsets and how many number of subsets are there. This is the third thing that you need to remember. What are subsets? So here we know that if a set has n elements, there are 2 raised to the power n subset of it. If a set has n elements, there are 2 raised to the power n subset of it, where this 2 raised to the power n, okay, remember this number. In this 2 raised to the power n, that set is also included and the null set is also included in that. Okay, for an example, suppose if I ask you what are the, tell me the subsets of, write all the subsets, or we can say write all the subsets of, if I take any set, let's say 1 comma 2 comma 3, I take this set and I want you to write all the subset. So subset is what? Subset is also a set that is formed by the elements of the given set. If I want to make it subset, how can I make it subset? Its subset will be, either I can just take 1, this is the subset because this is formed from these elements, or I can take 2, or I can take 3, or I can take 1 comma 2, or I can take 1 comma 3, or I can take 1 comma 2 comma 3, or I can take nothing, which is null set, which is 5. So how many subsets do we have? Okay, how many subsets do we have for this set? Because there are 3 elements in it, we can see 2 raised to the power 3 subset, 1 comma 2, 1 comma 3, and also we have 2 comma 3, 2 comma 3, and then we have 1 comma 2 comma 3. Okay, for this set we have 8 subset, 2 raised to the power n subset. If there are 3 elements in it, there will be 2 raised to the power 3 subsets. There will be in total 8 subsets of this set, as we can see over here, right? Now, see, phi is subset of every set. This is known as null set. I hope you know that. Null set. Null set means that it doesn't have any element. Okay, so phi is a subset of every set. You take any set, it's one of the subset is going to be a null set. And then this is how we can make subsets. Like here, first of all, I'm taking only one element. Like I'm only taking 1, then 2, then 3, then I'm taking two elements, and then I have taken all the 3 elements over here. Right? These are all the subsets of it. Okay. So now, what is relation? How do we define relation? Relation is nothing but, okay, all the subsets of A cross B. I have a slide prepared for that. Let me directly show you the slide where we have the definition of relation. See here. Okay, relation defined from set A to set B, which we represent like this. There's a relation from A to B is a subset of the set A cross B. Okay, all the subset of set A cross B will define a relation from set A to set B. Okay, now relation defined from A to B is a subset of A cross B. If I want to define relation from B to A, right, that will be a subset of B cross A. Relation defined from B to A will be a subset of B cross A. We also define relation from set A to set A only, which is known as a relation defined on set A. That will be a subset of A cross A. Okay, so any subset of A cross B will be a relation from A to B. Any subset of B cross A will be a relation from B to A. Okay, so this is how we can define the relations. Now let's talk about functions. Okay, now this is the time for functions. Now what is function? Function is a special type of relation. Function is a special type of relation. Now what is the speciality of this particular relation? Okay, the speciality of this particular relation is that we use every input. That is the first rule. Okay, the first rule is use every input. Okay, this rule is in the definition only. See the definition of functions. Functions is a relation defined from set A to set B. Function is a relation. Okay, let's understand this definition. Function is a relation that is defined from set A to set B such that all the elements of set A are related to only single element in set B. This is the first rule, guys. Now that all elements of set A, let me highlight this portion, all element of set A. This is the first rule, that we need to use every input. Okay, if I want to define a function from set A to set B, if I want to define a function from set A to set B, I will be using all the inputs, all the elements of set A, all the elements of set A. So basically use every input. Okay, is related to only single, element in set B. This is the second condition. There are only 2 conditions. Okay, the second condition is, okay, the second condition is basically that there should be only unique output. Okay, use all the inputs, and the second condition is unique output. These are the only 2 conditions. That's it. Okay, we need to use all the elements of set A, and there will be a unique output. See, very easily you can understand functions like this. Functions is like a calculator. Like there are many things in the calculator that we use. Correct? Suppose if you put some input in the calculator, like what is 2 plus 3? It is going to give you a unique answer, right? It is not going to give you more than one answer. Unique answer means that you are not getting more than one answer. You are only getting one particular answer, that this will be the answer for this question, right? Like what is 2 raised to the power 5? There will be a unique answer. 2 raised to the power 5 is 32. Calculator is not giving you multiple answer. So that's the thing. You need to use every input, and you can't have multiple output for a single input. There will be a unique output. You can't have multiple output for a single input. Let me show you some example. Example 1. Suppose there is a set A, there is set B. Okay. Let me show you these examples in the next slide. Suppose there is set A and there is set B. Example 1. In the set A, we have few elements. Okay. Let's say there are 3 elements. These 3 dots will represent 3 elements in the set A. They can be anything. That they can be A, B, C, or 1, 2, 3, or 4, 5, 8, whatever. Input can be anything. Okay. So there are basically 3 input. And in the set B, let's say there are 3 output as well. Okay. Let's say there are 4 output in set B. Right. Now, if I define a relation like this element is related to this one, this is related to this one, and this is also related to this one. Okay. And this element is related to this one. So now whether this is a function or not, this is a relation. Definitely this is a relation because there is some relation from set A to set B. Okay. So this is included in relation, but whether it will be called a function or not. So this is not a function. This is not a function. This is not a function. Why? Why it is not a function? Because see, at one input, we are getting multiple outputs, right? We are getting more than one output in one input. That will not be a function. Okay. See, the elements of set A are input, the elements of set B are output. At this one input, we are getting multiple outputs. So that is why this will not be a function, right? Suppose if you ask what is 2 plus 3, I will give you multiple answer. That will be wrong, right? So at one input, we can't get multiple outputs. So not a function because more than one output. Okay, because there is more than one output at an input, so we are not getting, this is not a function. Now let me show you example 2. Suppose this is set A, set B. There are 3 elements in set A, there are 3 elements in set B, and this. This will be a function or not? This is my question. Okay. Now this will be a function. This is a function. This is a function. See, it is not violating the condition, those 2 conditions. There are only 2 conditions. This is not violating any of those 2 conditions. What are the conditions? The condition is, the first condition is we should use all the inputs. Are we using all the inputs? Yes, we are doing that. Okay. We are using all the inputs. That's good. The first rule checked. Now what's the second rule? We should not get multiple output at an input, and we are not getting that. Right? At this input, we are getting only one single answer. At this input, we are also getting one single answer. At this input, we are also getting one single answer. So we are not getting multiple answer for a single input. Although all these 3 inputs are giving the same output. That works. Okay, that is not violating the condition. It happens all the time in functions. It happens all the time in functions that at one single input, at basically 3 different inputs and same output. That is allowed. Basically, conversion is allowed, but the diversion is not allowed. This is how you can remember the rule. Diversion is not allowed because here at one input, we are getting 2 different outputs. What is happening over here? Here we are having 3 different inputs and we are getting the same output. That is okay. That is okay. Like for an example, fx is equal to x square. F of x is equal to x square. This is a function. This is a function. Here at 2 different input, I can show you same output. Like if you put x as -1, like what will be the value for f of -1? What will be the value for f of 1? Are we getting the same value? Yes. -1 square will also be 1 and 1 square will also be 1. So 2 different inputs, we are getting the same output. Like what will be the value for f of -2? F of -2 will be 4 and f of 2 will also be 4. At 2 different inputs, we are getting the same output. That is okay. This is still a function. This is still a function. So you can write down this as a rule that in function, we can get same output at different inputs. That works. Okay, different inputs, same outputs, that's okay. But one input and different outputs, that is not okay. This is not a function, this is a relation, but this is not a function. Are we clear? So only two conditions. We need to use all the elements of set A. We need to use all the elements of set A, and there shouldn't be multiple outputs. There shouldn't be diversion. There should be conversion. Conversion is allowed, diversion is not allowed. Okay, simple. Now, example 3. Tell me whether this is a function or not. There are 3 inputs, okay, and there are these 2. This is related to this element, okay. This is related to this element. Is this a function or is this not a function? That is my question. Now, the first rule, we should be using all the inputs. Are we using all the inputs over here? We are not using all the inputs over here. So this is not a function. Not a function. Why? Because it is violating the first rule only. Because not using all the inputs. Basically, all the buttons in the calculator should work. All the input should work. All the input should work. This input is not working over here, right? This input is not working over here. We are not getting any output for this input. So that is why this is not a function. Okay. Example 4. This set A, set B. Okay. There are 4 inputs. Okay. There are 3 outputs. Now, this is related to this one, this is related to this one, this is related to this one, this is related to this one. Is this a function or is this not a function? So, first rule, are we using all the inputs? Yes, we are using all the inputs. Second rule, is there any diversion? No, there isn't any diversion. There is only conversion. Conversion is allowed. Diversion is not allowed. So, it is following both the rules, right? If we are using all the inputs and we are not getting multiple answer at a single input, right? For this input, we are only getting this one single answer. For this input, we are only getting one single answer. This input, we are only getting one single answer. So we are not getting multiple answer for a single input. Okay, so this is a function. This is a function. Okay, this is a function. Are we clear? Yeah, right? Now, see, one element in the set B is not working. We are, right? This element is not working, but that is not a problem. That is not a problem. There are only 2 conditions. Input should work and there shouldn't be diversion. These are the only 2 conditions for a function. That's it. Okay. So, yeah, even if it is not working, that's not a problem. That's not a problem. So, yes, this is a function, definitely. Right? Now, let me show you few more examples. Which of the following relation from or on set A, from set A to set B, set A to set B is a function? Okay, this is our question. Which of the following relation from set A to set B is function, where set A is, let's say, 1, 2, 3, and set B, let's say, is 10, 11, 12, 13. Okay, so this is set A, this is set B. Now, which of the following relation from set A to set B is a function? That is our question. Now, first relation, option 1. Okay, the first one. Suppose I define this relation like this, that 1 is 1 comma 10, 1 comma 10, 2 comma 10, 3 comma 10. Is this a function or is this not a function? Is this a function or not? Relation R is defined like this: 1 comma 10, 2 comma 10, 3 comma 10. It means that if I represent it diagrammatically, this is how I will represent it. This is set A, this is set B. Okay. In the set A, we have 3 elements, 1, 2, 3. Okay, we have 3 elements. These elements are 1, 2, and 3. In the set B, we have 4 elements, 10, 11, 12, 13. Now, what is happening over here? That 1 is related to 10, 2 is also related to 10, 3 is also related to 10. Basically, see it like an input-output game. What are the inputs? Inputs are 1. Here we have input as 2. Here we have input as 3. So, are we using all the inputs? Yes, we are using all the inputs. 1, 2, 3. We have used all of them. So, the first rule is satisfied now. Now, are we getting multiple answer at a single input? This is not happening. Okay, these 3 inputs are giving us the same answer. That works. There is a conversion. These 3 inputs are giving us the same output. Okay, that is not a problem. So, this is a function. This is a function. Okay, this is a function. Not a problem. Now, if I give you second example, let me write the second example over here. We are going to be doing many examples so that we have clarity about this. Okay, second relation I'm defining like this: 1 comma 10, 2 comma 11, 3 comma 12, and 1 comma 13. Okay. Let me write it again: 1 comma 10, 2 comma 11, 3 comma 12, and 1 comma 13. Is this relation a function or not? That is my question. So, are we using all the inputs? Yes, we are using all the inputs. Here the input is 1, here the input is 2, here the input is 3, but then again the input is 1. Basically, what do we mean by here? We mean that at 2 different inputs, basically at 1 input, we are getting 2 different outputs. If I put input as 1, I am getting 10 also, I am getting 13 also. There is a diversion. At 1 input, we are getting 2 different outputs. That is not allowed in function, right? So, this is a relation. This is not a function. If you see it diagrammatically, this is how it will look like. This is set A, set B. There are elements 1, 2, 3 in set A. There are elements 10, 11, 12, and 13 in the set B. See, 1 is related to 10, 2 is related to 11, 3 is related to 12, but what's the problem? 1 is also related to 13. So see, at 1 input, we are getting 2 different outputs. There is a diversion, you can see. So diversion is not allowed, conversion is allowed. At 3 different inputs, we can get the same output. But this will not work. This is not a function. Okay? This is not a function. So this is how we check whether it is a function or it is not a function. Let me give you more examples on this. Let me write example 3. Okay, there is a relation defined like this. Let's say 1 comma 10 and 2 comma 10. Is this a function, everybody? Is this a function or not? So the first rule, are we using all the inputs? We have used 1, we have used 2, but we have not used 3 yet. We should be using all the inputs. So this is not a function. Not a function. Why? Because input 3 has not been used. We should be using all the inputs. That's the first condition of function. We should be using all the inputs. We are not using over here all the input. So this is not a function. Example 4. So basically this is a relation. This is not a function. As I told you, function is what? Special type of relation. The third one is a relation, of course, from set A to set B, but this is not a function from set A to set B. Okay. Now, 1 comma 10, 2 comma 11, and 3 comma 11. Is this a function? Is this going to be function? 1 comma 10, 2 comma 11, 3 comma 11. So the first rule, are we using all the inputs? Yes, we are using all the inputs. We have been using 1, then we have used 2, then we have used 3. Okay. And there shouldn't be multiple use of the input basically, right? All the inputs should be working, but it shouldn't be working too much. But they are not, right? At one input, we are getting unique output. For every input, we are getting only one single output. Okay, if you represent it diagrammatically, this is going to show you like this. This is set A, set B, we have 1, 2, 3, then we have 10, 11, 12, 13 over here. So 1 is related to 10, 2 is related to 11, 3 is also related to 11. It's okay. This is a function. This is a function. Because it is satisfying both the rules. All the inputs are working. We are not getting divergent answer, right? It's not happening that at one single input we are getting multiple answer. This is not happening over here like in the previous question. Here what happened in this question? What happened in this question? 1 is related to 10, 1 is also related to 13. At one input we are getting two different outputs, so this is not a function. But if I remove this thing, now this has become function. Now this has become function that 1 is related to 10, 2 is related to 11, 3 is related to 12. We are using all the three inputs. Now this is a function. But here this is not a function because at one single input we are getting two different outputs. Okay. Now if you have understood about functions, let me tell you what are domain and range. Okay. But before moving towards domain and range, I also want you to understand how do we see that whether a graph is a graph of a function or not a graph of a function. Okay. So in given graph, draw all possible lines parallel to y-axis. This is known as vertical line test. This test is used to check whether the given graph is a graph of a function or not. So what do we do over here? We draw all the vertical lines. If the vertical lines are cutting the graph at more than 1 point, see, if any line cuts the graph at 2 or more than 2 points, it is not a function. Every vertical line should be cutting the graph only at 1 point. Let me give you two examples. Example 1. Suppose if I give you the graph like this. Okay. Now example 2. Tell me which of the following graph represents the graph of a function. Now, which of the following graph represent the graph of a function? So the vertical line test says that if you draw any vertical line, wherever, all the possible vertical line, if you draw any vertical line, if the vertical line cuts the graph at 2 or more than 2 points, or I can say if the vertical line cuts the graph more than 1 point. See here, if I draw a vertical line, it is cutting the graph at 2 different points. It is cutting the graph at 2 different points. So it is not a function. Now what's the problem in cutting the graph at 2 different points? See what is happening over here, that at these 2 points, let's call it point A, let's call it point B. At these 2 points, the x coordinate is same. Because this is a vertical line, the x coordinate is going to be same. Let's say that x coordinate is x1 over here. Then here also the x coordinate will be x1 only, right? The x coordinate is same at these 2 points, but the y coordinate is different, right? Y coordinate, let's call the y coordinate over here as some y1, and let's call the y coordinate over here as y2. So here x1 is related to y1, but here x1 is related to y2. That's the problem. At one single input, we are getting two different outputs, right? At one single input, we are getting two different outputs, y1 and y2. x1 is related to y1, x1 is also related to y2. So that is why this is not a function. This is known as vertical line test. So if you draw a vertical line, it cuts the graph at more than one point, then it is not the graph of a function. This is not a function. I hope you have also understand the reason behind it. What's the reason behind it? Because the x coordinate are same at these 2 points, but the y coordinate is different. So x1 is related to y1, x1 is also related to y2. This point is x1 comma y1, then this point is x1 comma y2, right? So at one input, we are getting two different outputs. So this is not a function. This is not a function. Okay. This is not a function. But is this a function? Yes, because this is passing that vertical line test. Wherever I draw a vertical line, this vertical line is not cutting the function at more than one point, right? This is not cutting the graph at more than one point wherever you draw a vertical line. So yes, this is a function. This is a function. Okay, are we clear? This is the graph of a function. This is not the graph of a function. Example 3. Tell me whether this is the graph of a function or not. A circle. Is this a graph of a function? This is not a graph of a function, because if I draw a vertical line, this vertical line cuts the graph at more than one point, right? So this is not a function. Okay. Now example 4. Is this a function? Yeah, this will be a graph of function because it is passing vertical line. This is passing vertical line. Wherever you draw a vertical line, it is only cutting it at one point. So yes, this is function. So I hope you have understood that how to identify whether the graph is a graph of a function or the graph is not a graph of a function. How to identify that. I hope you have understood about that. Okay. Like y is equal to modulus of x, right? So everyone knows what's the graph of y is equal to modulus of x looks like. If you don't know, you will know it in a while. Okay, this graph. Is this a graph of a function or not? Yes, this is also a graph of function because it is also passing a vertical line test. If you draw a vertical line, it is only cutting it at one point. So yes, this is a function. This is a function. And we call this function as modulus function. This is the graph of y is equal to modulus of x. Okay. Right? So this is also a function. Now there's a very important term in function, which is domain, range, and codomain. These three terms we need to understand. See, very simple. If a function is defined from set A to set B, if a function is defined from set A to set B, then this entire set A is known as domain. This entire set A is known as domain. We also call it input, or we call it inputs, right? All the inputs are working, correct? We know that for a function, all the input has to work. So all the inputs, these are known as domain, or we call it input. Okay, if a function is defined from set A to set B. Okay. Now, this entire set B is known as what? Many students do this mistake that they call set B as range. This is not range. Set B is not range. Set B is known as codomain. It is known as codomain. This entire set B is known as codomain. Entire set A is known as domain. Then what is range? If this is domain, this is codomain, then what is range? Range is a subset of B. Range is subset of B, or we can say codomain. Range is subset of codomain. Okay. Basically, what is range? Range means output. Range basically means outputs, right? Collection of all the outputs. Okay. Collection of all the outputs. That is basically we mean by range. Okay. For an example, suppose if I define like this is set A, this is set B. Here we have 1, -1, 2, -2, and in set B we have elements 1, 4, 9, okay, and 16. Now, this function is defined like this, that 1 is related. Okay, this function is y is equal to x square function. Fx is equal to x square. We are defining the function like this. Fx is equal to x square. Okay. So now 1 will be related to 1 because square of 1 is 1. Square of -1 is also 1. Right? So -1 square is also 1. 1 square is also 1. 2 square is 4. -2 square is also 4. So first of all, is this a function? Yes, this is a function because there are only two rules. What are the rules? All the inputs should be working. Okay. All the inputs are working and we are not getting divergent, right? Divergent view. We are only getting convergent view. That works. Okay. At two different input, if we get the same output, that is not a problem. So yes, of course, this is a function. This is a function. Now we want to mention its domain, its codomain, and its range. Now, what is domain? Domain is entire set A. So if I ask you to write domain, you can simply write mention all the elements of set A, which are 1, -1, 2, and -2. That is domain. If I ask you codomain, you can simply mention all the elements of set B, that these elements of set B are 1, 4, 9, 16. This is going to be codomain. But if I ask you what is range? Now, what is range? Range is collection of outputs. Okay, what are the outputs? Outputs are only 1 and 4. We are not getting 9 and 16 as output over here, right? 9 and 16 is not the output over here, right? These two elements are not in the outputs. So the collection of output is 1 and 4 only. This will be counted in range. As simple as that. Okay. So range is what? It is the subset of codomain. Range is a subset of codomain. Okay. Range is basically part of set B. See, all the outputs are not achievable sometimes. Like here we can see that 9 and 16 are not achievable outputs. We are not able to get 9 as an output. Okay. Because to get 9 as an output, I should have 3 over here and we don't have 3 over here. This is the question right now. Okay, so we can see that only 1 and 4 are the outputs. These are in the range. So this is the basic understanding of domain, range, and codomain. Domain is entire set A, or we call all the inputs. Codomain is set B, and range is the subset of set B. Range is the subset of set B. Now this is not the only meaning of domain, codomain, range. Let's understand. See, this is the entire set of all the pre-images. We call domain as set of all the pre-images. Okay. Or values of x. Okay. Values of x which is satisfying. Suppose I give you a question like this. Fx is equal to 1 by x. Okay. Now, what is the domain of this set? So here the domain will be all real number except 0, right? So if a function is given as y is equal to f of x, see, I will discuss about this example later on in detail, domain, range, codomain, everything. But for now, you need to understand that if a function is defined as y is equal to f of x, the values of x is known as domain. What are the values of x which are permissible, which we can put inside the function? These are known as domain. values of x, or we can say inputs that we can put inside the function, that is basically domain. Or in the graph, x-axis covered by the graph. The entire x-axis graph has covered which portion of the x-axis, that will be the domain of this function. Okay. Now what is range? Range is set of functional images, or we can say set of outputs. What are the outputs we are getting? That is range. In the graph y is equal to fx, the values of y is known as range. Like what are the values of y? What is the range of y? That is known as the range of this function. Okay, or y-axis covered by the graph. Right? So I hope you have understood about these terms. Now, let me show you some graphical example. See, suppose a graph is formed like this. Okay. Now, by looking at the graph, what can you say? What is the domain of this graph? First of all, what is the domain of this graph? See, graph is like this. This is the graph. It is starting from this point. Then it is going downwards. Then this is the graph. Okay, this is the graph. Now, what is the domain? Domain is basically the x-axis covered by the graph. Okay, what are the positions? See, the leftmost x coordinate is what? And what is the rightmost x coordinate? So you can see that the leftmost is -3 and the rightmost is +3. See, this is -1, this is -2, this is -3. So the leftmost is -3, the rightmost is +3. So the domain of this graph will be -3 to 3. So -3 to 3, close bracket, this is the domain. These are the values of x. What is the range? What is the range of this graph? The range is basically the y-axis covered by the graph. Now, what is the minimum value of y? What is the minimum y coordinate? Minimum means the lowest one and the highest one. Basically, the lowest and the highest point. If you can see that in a graph, that this is the lowest point, this is the highest point. If you can see that in a graph, you can comment about the range very easily. Okay, what's the lowest point of this graph? This is the lowest point. What's the y coordinate over here? Y coordinate is -2, right? This is -1, this is -2. And what's the highest point? Highest point is this one. What's the y coordinate over here? That is 3. So if I ask you what's the range, range will be -2 to 3. Range is -2 to 3. This is the range. So by looking at the graph, we can comment about its domain and range. Okay. So sometimes, basically, we need to have entire understanding about domain, range. And now, first of all, I've told you the understanding about domain and range from defining a function. Like a function is defined from set A to set B. If you can directly see that these are the elements in set A, then that is domain. The elements of set A is domain. Here the function is not given like that. Here they have directly shown us the graph of the function. So if we also have the graph of the function, we can comment about domain and range, right? That domain is the x coordinate, x-axis covered by the graph. The leftmost x coordinate is -3, the rightmost is +3, -3 to 3. These are the values of x. These are the inputs, right? So this is the domain. Range is the outputs. Okay, so domain you see on the x-axis and you see range on the y-axis. That the highest point and the lowest point, that's where you get the range, right? Okay, now, so here first of all they are asking us what is the value for f of -1. Okay, what do we mean by it? It means that if when the x coordinate is -1, what is the y coordinate? When the x coordinate is -1, what is the y coordinate? Or in other words, I can say that when I put input as -1, what's the output in that scenario? Okay, so when the input is -1, see, this is the input -1. When the input is -1, when the x coordinate is -1, you can see y coordinate as -2. When the x coordinate is -1, y coordinate is -2. So f of -1 is equal to -2. Okay. This is a function, right? This is a function, right? Because it is passing the vertical line test as well. So of course this is a function. Okay, so the value for f of -1 is -2. For what values of x is f of x is equal to 2? For what inputs basically the output is 2? Y coordinate is 2. So see, y coordinate 2 is over here, y coordinate is 2 over here. Because on a horizontal line, y coordinate is same everywhere. Okay. On a horizontal line, y coordinate remains same everywhere. So here the y coordinate is 2, here also we have the y coordinate as 2. Okay. So what is the x coordinate at these 2 points? That's what the question is asking us. That for what value of x, f of x barabar 2. So we can see here the x coordinate is 1. Okay. So the values of x is either 1. At 1 we are getting 2, or also at minus 3. Here the x coordinate is minus 3. At minus 3 we are getting 2 again. So x is equal to 1 or minus 3. Or I can say in other words that if you check the value for f of 1, if you check the value for f of minus 3, both of these values will be what? When the x coordinate is 1, y coordinate is 2. When the x coordinate is minus 3, again the y coordinate is 2. So for these two values of x, we are getting the same output that works in a function. That happens all the time in a function, right? That happens all the time in the functions, that two different inputs we are getting same output. But it should never happen that at one input we get two different outputs. That will not be allowed. Like we can't get two different values of f of 1. F of 1 can't give two different values. Like f of 1 is equal to 2 and f of 1 is also equal to 5. This will not be a function in that case. Okay, because at one input we are getting two different output. That will not be allowed in a function. Okay, so that's the thing. Now state the domain and range of function. We have already done that. Okay, on what interval the function is increasing and in what interval the function is decreasing. So increasing means that when the values of, see, when I'm moving towards right, if the graph is going upward, then the graph is increasing function. Basically, if I increase x, the y is also increasing. That means that it is a increasing function like this. This is an increasing function. See, if I'm moving towards right, the price is increasing. Or you can understand it like in a price or day, right? Suppose these are days. Okay. This is time and this is money. Okay. So you can see that yes, okay, the money is increasing. The price of the stock is increasing. So this is an increasing function. Okay. In the similar way, this will be a decreasing function. Moving towards right, the graph is going downwards. This will be a decreasing function. Like here, where can you see the graph as decreasing? Where can you see the graph as increasing? So see, the graph is decreasing till this point. Then after that, the graph is increasing. So it is increasing in the interval from this point till this point. It is continuously increasing. You are moving towards right, it is not going downwards. Suppose it starts to go downwards, then now it is decreasing in this scenario. Okay. So basically, on what interval the function is increasing? The function is increasing from x is equal to -1 to x is equal to 3. Okay, so -1 to 3. That will be our answer. From -1 to 3, we can see that the graph is increasing. Okay. On what interval the graph is decreasing? Decreasing in the interval of, see, from this point to this point, it is decreasing, right? It is decreasing. So what are the x coordinate? So the x coordinate over here is -3. Here the x coordinate is -1. So from -3 to -1, decreasing in -3 to -1. Okay, and increasing from -1 to 3. Decreasing from -3 to -1, and then from -1 to 3, it is continuously increasing in this interval. Okay, are we clear? Estimated value of f of 2, the value for f of 2, yes. So at x is equal to 2, what is the value we are getting? So we are getting value very close to 3. Okay, they are also telling us to estimate which of the following option will be right. What will be the value at 2? It is very close to 3, right? It is more than 2.5, it is very close to 3, so we can say that, yeah, it will be around 2.8. Okay, we are just estimating it. Now, estimated value of x such that f of x is equal to 0. So where the function is going to be 0. See, f of x is equal to 0 means that where the function is cutting the x-axis. Basically, they are asking us the points where function or where graph cuts the x-axis. Basically, they are asking us the points where the graph cuts the x-axis. Okay, that's the thing. So we know that graph is cutting the x-axis at this point and then again at this point. These are the 2 points where the graph is cutting the x-axis. Okay, so that's what they are asking us. What's the value for x where the value for function becomes 0? See, you need to understand. When the graph is above the x-axis, the value of function is positive. When the graph is below the x-axis, the value of the function is negative. Okay, and when the graph cuts the x-axis, the value of function is 0 in that case. Okay, for an example, let me show you from these are days and these are price. Okay, price of a stock. Or like here you can say that price is 10 rupees and then price is going down. Now the price has become 2 rupees. Okay, here the price is 2 rupees now. When this graph cuts the x-axis only, what will be the price in that case? The price will be 0 rupees now. Right? When the graph cuts the x-axis, the price is 0 rupees. If the graph goes below the x-axis, now what will be the price? Price will be negative. Okay, although it never happens, but just an example so that you are able to understand. When the function is above the x-axis, the price is positive. The value of the function is positive. When it is below the x-axis, the value of the function is negative. And when graph cuts the x-axis, the value of the function is 0. So that's what they are asking us, that where the graph is cutting the x-axis. So almost this point is what? 0.23, right? Almost like that. It is just less than 0.5. It is not exactly between 0 and 1. This is just less than 0.5. Okay. So just less than 0.5. Yeah, 0.3 will work. Okay. So it is almost like 0.3, 0.2, 0.3. We are just estimating. Okay. Now, and also at this point is -1, this point is -2, and this point is -3. This is exactly in between -2 and -3. This is basically -2.5. Yeah, so these are the two values we are getting where the function is becoming 0. So in this example, we have learned to use graph to understand and basically, answer question about graph like domain and range and everything. Okay. Cool so far. Now let me take you to the types of functions, different types of functions. Let's understand about that. Okay, first of all, we'll be learning about polynomial functions. What are polynomial functions? So polynomial functions you have already seen in your childhood. For an example, quadratic polynomial. Okay, you have seen quadratic polynomial, you have seen linear polynomial. Okay, these are basically polynomial function. You have seen cubic polynomial. So first of all, we'll be learning all about these polynomial functions because it is very important. Later on in quadratic equation, you will again see these functions. So we are going to start from the basic about what is polynomial functions. Okay, what is factor theorem? I will also be introducing that. Okay, that is also very important. Okay. Till now, what you can do, if you want something for homework, what you can do, you can practice the NCERT exercise, on which of the following relation is a function. You have done those type of question in the classes. Now you can practice that. Okay, pick up your NCERT textbook and you can practice from there, like which of the following, you know, relation is function. Okay. Now polynomial function. So polynomial function is defined like this. The general definition of polynomial function, f of x is equal to a naught plus a1 into x plus a2 into x square plus a3 into x cube and so on up to an into x raised to the power n. This is how a polynomial function looks like. This is a polynomial of degree n. Is a polynomial of degree n. This is the polynomial of degree n. Basically, the highest power of x is known as the degree of that polynomial. Okay, highest power of x is known as the degree of this polynomial. Suppose the highest power is till 2 only. Suppose this is the function like this. Now this is a quadratic polynomial. The highest power is till 2. Suppose if the highest power is till 1 only. Okay. Now this is a linear polynomial. And suppose this is like this. There is no variable only. There is only constant. Fx is equal to some constant. This is known as constant polynomial. Okay. So basically quadratic, cubic, degree n, degree 5, whatever we can get. This is the general picture of a polynomial. This is a general picture of a polynomial. Are we clear till now? Is a polynomial of degree n. So basically, what is the condition for a function to be a polynomial function? Here the condition is that power should be a whole number. Basically, power of x, or condition is that power of variable, here the variable is x, this function is in terms of x. So power of variable should be a whole number. That's the thing. Power should not be negative, power should not be a fraction, power should be a whole number. Power of x can be 0 or 1 or 2 or 3 or 4, which you can see over here. Okay, then we call this as a polynomial function. So this is a polynomial of degree n, right? For an example, if I ask you that, let me show you few examples first of all of polynomial function. Okay, which of the following is a polynomial? Okay, which of the following is a polynomial? For an example A, fx is equal to root x plus 3. Example B, fx is equal to 2x plus 5. Example C, fx is equal to x square minus x plus 2. Example D, fx is equal to x square plus root x, or x square plus 1 by x, let's say. Okay. Example E, fx is equal to x square plus root x. Which of the following is a polynomial? That's the question, right? Fx is equal to x square plus root 2, okay, or root 2 times x we can write, g. Fx is equal to 1 upon 2x plus 5. Fx is equal to 3x cube plus 1. Now, which of the following is a polynomial? That's the question, okay? Now, first of all, option A. Is this a polynomial? This is not a polynomial. Why it is not a polynomial? Because power of variable is not a whole number over here. The power of variable x is 1 by 2. As I told you, in a polynomial, the power of x should be a whole number. The power of x is not a whole number. This is not a polynomial. Now, the example B. Is this a polynomial? Yes, this is a polynomial because the power of x is a whole number over here, right? Power of variable, only one condition. There is only one condition for a polynomial. What's the condition? That power of variable should be a whole number. That's it. Okay, we are not worried about anything else. 2x plus 5, this is a polynomial. In fact, if I also write 2x plus root 5, that is also a polynomial. 2x plus root 5, it is still a polynomial. Okay, because power of x is a whole number. Root 5 is a constant, it is just a number, nothing else. Like 2 or 5, root 5 is also just a number. Okay, this is still a polynomial. The condition is on the power of variable, that's it. The third example, this is also a polynomial. This is known as quadratic polynomial. This is known as quadratic polynomial. This is also a polynomial. Okay, the option B is linear polynomial, and this is a quadratic polynomial. Quadratic polynomial. Now, example D, is this a polynomial now? Okay, x square plus 1 by x, is this a polynomial? No, this is not a polynomial because here we have 1 by x. Basically, what's the power of x? The power of x is minus 1. And as I told you, power of x should be a whole number. Okay, here we have x raised to the power minus 1. So this is not a polynomial. This one, is this a polynomial? No, because we have x raised to the power 1 by 2. This is not a polynomial. Now, is this a polynomial? Yes. Because we have x square, here we have x raised to the power 1. Power of x is a whole number, that's the only condition. Even if we have root 2 over here, that's not a problem. This is just a number. You can write 1.7 something, right? So this is a polynomial. Now, is this a polynomial? This is not a polynomial because x is written in the denominator. X is written in the denominator. This is not a polynomial. Okay, because see, D example and G example are the similar kind of examples. Both of them are not a polynomial. Is this a polynomial? Yes. X raised to the power 3. Okay, so this is a polynomial and we call this as a cubic polynomial. As a cubic polynomial, we call it like this. Are we clear till now? Okay. Now, there are some graphs of polynomial which are very, very important. Okay. Important graph. Important graph of polynomial function. Okay, there are few polynomial functions which are very, very important and the graphs are very, very important. Okay. Now, see, the first one is fx is equal to x square. Fx is equal to x. First one, let's say fx is equal to x. Okay. Then the second one, fx is equal to x square. We will be learning about that. So now what is fx is equal to x? This is simply y is equal to x line. Fx is equal to x is simply y is equal to x line. So this line passes through the origin. Everybody knows that. This line passes through the origin. This is the line y is equal to x. This is fx is equal to x. This is the graph for it. Okay. Very simple graph. Basically, this passes through 1, 1, 2, 2, through 3, 3, and so on. You can see that when x is 1, y is also 1. When x is 2, y is also 2, because y is equal to x, fx is equal to x. The input and the output, both of them are same. This is known as identity function. This is also known as identity function. Okay. Identity function means that the input and output are same. Y is equal to x. See, we know that x is input, we know y is output. And if I say y is equal to x, it means input and output are same. Basically, this graph passes through 1, 1, 2, 2, 3, 3, 4, 4, minus 1, minus 1. It is a straight line passing through origin 0, 0. This is known as identity function. Fx is equal to x. Okay. What is the domain and range of this graph? We can check it. from the graph only. See, x-axis, entire x-axis is covered by the graph. This line is never ending, right? This line is going never ending. Entire x-axis is covered. Also, entire y-axis is covered. Basically, if I ask you what is the rightmost point, what is the rightmost point of this graph? The rightmost point of this graph is not known because it is going to, straight line is never ending. I am ending it over here. It doesn't mean that it ends over here. It is never ending. This is straight line. Okay. It goes. If I ask you what's the rightmost point? Rightmost point is infinite. What is the leftmost point? That is infinite. So basically, the domain is all real number. And if I ask you what's the range? Range means the topmost point. You can't see the topmost point in this. Okay. Range is also from minus infinity to infinity. So its domain and range, you can write it over here. Its domain is, or x belongs to all real number and y also belongs to all real number. Domain is all real number, range is also all real number. Okay. Now, let's talk about fx is equal to x square. Let's talk about this one. Fx is equal to x square. Its graph is going to look like this. This is x-axis, this is y-axis. This is basically y is equal to x square. Fx is equal to x square, or I can say y is equal to x square. So we want to plot this graph. See, plotting graph is very easy. Very easy. See, when I put x is equal to 0, y is also equal to 0, correct? When x is 0, y is also equal to 0. When x is 1, what's the value for y? The value of y will also be 1. When x is 2, the value of y will be 4. Y will be 4 in that case. When x is 3, y will be now much bigger, 9. So if you connect these points, you get something like this. This is how we draw the graph, very easy. Just put the input and get the output. In the similar way, when x is minus 1, what is the value for y? The square of minus 1 is again plus 1. When x is minus 2, what's the value for y? It will be plus 4. When x is minus 3, the value of y will be plus 9 and so on. So its graph will look like this. This is the graph of y is equal to x square, a parabola. Okay. The graph of y is equal to x square is a parabola. Okay. Remember, very important graph. The graph of fx is equal to x square. This looks like this. It is the parabolic graph. At x is equal to 0, y is 0. At x is equal to 1, y is 1. At x is equal to 2, y will be 4. At x is equal to minus 2, again y will be 4. See, at two different inputs, we are getting the same output. When I put the input as 2, I am getting the output as 4. When I put the input as minus 2 again, I'll be getting the output as 4. At two different inputs, we are getting the same output. Okay, that works. This is a function. This is a function because it is passing a vertical line test. Okay, polynomial function. It is a type of a function. We are discussing types of functions. In the types of functions, first type we have learned about polynomial functions. Like, what are polynomial functions? There are linear polynomial. You can see over here, there are quadratic, there will be cubic and so on. There will be degree 4, degree 5, degree 6. There are many degrees polynomial. Okay, we are learning about that and some important graphs. Okay, if I ask you what's the domain and range for this graph? Now again, if I ask you what's the leftmost point, you can't comment about the leftmost point because leftmost point is minus infinity. What's the rightmost point? That is plus infinity. So its domain is all real number. X belongs to all real number. This is the domain for this one. But what's the range? For range, we have to comment about minimum and maximum value. Now, what's the lowest point of the graph? The lowest point is this point. What's the value of y over here? The value of y is 0 over here. So the minimum value of y is 0. Y is not less than 0. We don't have lower point than this. This is the lowest. And what's the highest? The highest point goes till infinity. So its range is or I can say values of y is close bracket 0 to infinity. The minimum value is 0. The maximum value is going till infinity. Range is basically output only. Okay, what's the minimum output? If I want the output as minimum, I will put the value for x as 0. 0 square will be minimum, right? Minus 1 square will be 1, minus 2 square will be 4, minus 3 square will be 9. Whose square is minimum? 0 square is minimum. So when I put x as 0, y is also 0. So 0 is the minimum value. Now what's the maximum value? Maximum value can go till infinity. If I put the value for x as 10,000, then 10 lakhs, 10 crore, right? So you keep doing that squaring, the maximum value can go till infinity over here. So this is the graph of fx is equal to x square. In the similar way, the graph of fx is equal to x raised to the power 4, the graph of fx is equal to x raised to the power 6, the graph of fx is equal to x raised to the power 8. Okay, all of their graph will be very similar graph. They have similar, I'm not saying exact same graph, they have similar graph. Similar graphs. See, you should have understanding about graph. That's very, very important. Fx is equal to x square, fx is equal to x raised to the power 4, fx is equal to x raised to the power 6, fx is equal to x raised to the power 8. All of their graph will be similar, and their graph will look like this, a parabolic graph. At x is equal to 0, y is 0, and then so on. All of their graph will be parabolic graph. Because you can see that when x is 0, y is also 0. At x is equal to 0, fx will also be 0. So at x is equal to 0, y is 0. When you put x as 1, y will be 1 again. But at x is equal to 2. In this one, we will get y as 16. 2 raised to the power 4. At x is equal to minus 2 again, we are getting the same value, 2 raised to the power 4. So all of their graphs will be similar kind of graph. Okay, all of their graph will be similar. Suppose if we plot them one by one on the right x-axis, y-axis, if I draw all their graph, all these graph on x-axis and y-axis, this is how it will look like. Okay, see, this is the graph of y is equal to x square. This is the graph of y is equal to x square, correct? At x is equal to 1, we are getting the value of y as also 1, but at x is equal to 2, we are getting the value of y as 4. Okay, at x is equal to 3, we will get the value of y as 9, and so on. At minus 2 also, we are getting the same value of y. Okay, at minus 2 also, at minus 1, we are getting the value of y as 1. This is the graph of y is equal to x square. The graph of y is equal to x raised to the power 4 will look like what? If I want to draw the graph of y is equal to x raised to the power 4, at x is equal to 0, y is still 0, so that is also passing through this point. Okay, at x is equal to 1, y will be 1 only for this one. But at x is equal to 2, y will be 16 now. 16 will be, this point is 4, 16 will be somewhere over here, let's say. So at x is equal to 2, this is how the graph of this looks like. Okay. See, at 1, 1 they are intersecting, and then this is the graph of y is equal to x raised to the power 4. So basically, you can see that both the graphs are similar. This is also parabolic, this is also parabolic graph. But the only difference is that after 1, now this graph is giving more values, right? The graph of y is equal to x raised to the power 4 is giving us more values, bigger values than the graph of y is equal to x square. At x is equal to 2, y is 4. Here at x is equal to 2, y is 16. It is giving us bigger values. So basically all of their graph will be similar. So all of their domain and range will be similar. If I ask you domain, their domain will be all real number. Domain is all real number, which are the values of x. X can be anything. But if I ask you about range, clearly the range is from 0 to infinity. For each one of them, the range is from 0 to infinity. Close bracket 0 to open bracket infinity. That's the thing. Very important graphs. Now, Let's talk about graph of fx is equal to x cube, or fx is equal to x raised to the power 5, or fx is equal to x raised to the power 7. All of their graph will be very, very similar. Okay, their graph looks like this. This is x-axis, this is y-axis. Now, if I want to plot the graph of y is equal to x cube, okay, now let's check about the points. At x is equal to 0, y is 0, so it is also passing through origin. At x is equal to 1, what's the value for y? It will be 1. At x is equal to 2, now the value of y will be 8. Okay, so it is like increasing in this interval. At x is equal to 1, y is 1. At x is equal to 2, it will be 8. At 3, it will be 27. So it's increasing. Okay. Now, what is happening in the left hand side? At x is equal to -1, we are also getting the value of y as -1. This point. At x is equal to -2, we are getting the value of y as -8. Because -2 cube, if we put x as -2, y will be -8. So its graph looks like this in the left hand side. Okay, so this is the graph of y is equal to x cube. This is the graph of y is equal to x cube. Similar kind of graph we see for this one, x raised to the power 5. Similar kind of graph we see for x raised to the power 7 also. Okay, the only difference will be, like if I plot the graph of y is equal to x raised to the power 5, it will look something like this. Okay, this will be the graph of y is equal to x raised to the power 5. But all of their graph have the same trend, a trend like this. Okay, a trend like this. We see the same trend for all of their graph. Okay, now what's the domain and range? That is most important when you look at a graph. Like what's the domain, what's the range that you can see in this graph? Okay, so domain is basically the values of x. Again, x can be any real number over here. And what's the range? Range is the values of y. Okay, the y-axis covered by the graph. And this graph, as you can see, is covering the entire y-axis. The maximum value goes till infinity. The minimum value. What's the lowest point of this graph? That is, we are not known. Na? There is the lowest point goes till -infinity. The highest point goes till +infinity. So the range for this graph is also all real number from -infinity to +infinity. This will be the range for this graph. Okay. This is about our polynomial function. Now, so the point to be noted is graph of polynomial is always continuous. You take any polynomial, whether you are taking linear or quadratic or cubic, you have seen the continuous graph. Okay, so graph is always continuous. Range of an odd degree polynomial is complete real number set R, as you can see in the graph of fx is equal to x cube. Correct? This is a odd degree polynomial. Why? Because it is a cubic polynomial, or a degree 5 polynomial, or degree 7 polynomial. Their range will be all real number. Basically, it covers the entire y-axis, as you can see over here. See, this graph is covering the entire y-axis. So all the odd degree polynomials, their range will be from -infinity to infinity, which is very important to remember. Okay, very important point. The second point is very, very important. Now, polynomial with leading coefficient 1 are called as monic polynomial. Okay, if the leading coefficient means the coefficient of highest degree, right? For an example, fx is equal to x square plus 2x plus 5, or fx is equal to x cube plus 5x square minus x plus 5. Suppose. So basically the leading coefficient is 1. Here the leading coefficient is 1. So if the leading coefficient is 1, this is known as monic polynomial. Okay. You can add one more point in it, in this. The next point is that range of even degree polynomial is never R. Okay, even degree polynomial cannot have its range as all real number, as you have seen in quadratic polynomial. Okay, like you have seen y is equal to x square, y is equal to x raised to the power 4. See, here the range is from 0 to infinity. So basically, if you take any quadratic polynomial, its graph is going to be like a parabola or any degree 4 polynomial. Okay, its range can never be all real number. Two important points that you should be taking from this class: the range of even degree polynomial, the range of odd degree polynomial. The range of all degree polynomial, odd degree polynomial is all real number. Odd degree polynomial can cover from minus infinity to plus infinity. But range of an even degree polynomial is never all real number. These are the two important points you should be taking from this class, from this polynomial. Okay, so that's it for the session today. In the next session, we'll be learning more about functions, we'll be learning about modulus functions and many more functions. So in the next class, I will see you again. Revise everything that we have learned till now. What are functions? In today's session, we first of all learn about functions. What are functions? The definition of functions. Then we have learned about polynomial functions. In the next class, I'll be teaching you about modulus function, greatest integer function, okay, fractional part function, their range, domain. There are a lot to talk about in range and domain. I have just given you an introduction of range and domain in today's session. There is a lot to talk about in range and domain. Okay, so we'll see each other again in the next session. Till then, take care. Tada, bye bye. Have a great day, guys.